Hello, Professor Sargent here with you again. Now that we know that except for vertical lines, we have functions when we are dealing with other types of lines. As a quick side note, horizontal lines, y stays constant. Although the graph is of a line, we call that a constant function. So we're concerned about defined and non-zero slopes for saying that we have a linear function f of x equals ax plus b. A is just the same thing here as the slope m. Don't know why some authors like to use different letters. I want to start off with the question of what is average rate of change? Average rate of change is dependent on two values of x. Let's say, for example, here we want to know the average rate of change of this linear function where x is 0 to x equals 1. That would be computed with f of b minus f of a all over b minus a, where b is the endpoint, the one further to the right, and a is the starting point, the one further to the left. So in this case, we would get 2 for the function value or y value minus negative 1. Oh, okay. I did not graph f of x equals 2x minus 1 there. Since I've gone up 3 and right 1, that's a graph of 3x minus 1. So y equals 3x minus 1, or f of x equals 3x minus 1. Okay, 2 minus negative 1, all over the 1 minus 0. 2 minus negative 1, same as 2 plus positive 1. We've got 3 over 1, so the average rate of change there is 3. That is the same as slope. They've simply renamed what we're calling x1 and x2 as a and b respectively. Therefore, f of x1 would be f of a. That's the y value when the x coordinate is a. And similarly, this would be our y2. So y2 minus y1. When you're dealing with a linear function, pick any pair of points and the average rate of change is going to stay the same. I could plot the point, it's going to be way up here somewhere, so I'm not going to try to be to scale to get this idea across. Put in 3 for x. 3 times 3 is 9. 9 minus 1 is 8. So it's up here somewhere. And say we want the average rate of change from 1 to 3. So a equals 1 and b equals 3. We'd have the 8 minus the 2 over the 3 minus the 1. 6 over 2, and that reduces to the same answer of 3. That's part of what makes a line, the fact that we have a constant slope between any pair of points. Now, if we're only moving 1 unit of x at a time, that's going to give us something even nicer to look at, but I'm going to save that for the next portion of this playlist. In the meantime, I want to point out here using the function y equals x squared minus 3. If you want to call that f of x or g of x, that is fine. that we, depending on the pair of points we pick, we're not going to have the average rate of change staying the same there. So let's say that we want to compute the average rate of change from -1 to 0. That marker just died, so from -1 to 0, I have here -1, -2, and 0, -3. You can quickly check those points really are on the graph. All right, so the ARC B is 0. The y-coordinate, or the function value at B, is -3. I'm going to subtract the -2 all over B minus A. So 0 minus -1, -1. -3 minus -2, that is -3 plus 2. So -1 over +1. We're getting an average rate of change of -1 between those 2 points. Really what that's giving you, this is not a line, it's giving you the slope of the line that connects those 2 points. And what the parabola is really doing in between there, its rate of change is kind of close to that, but it's going to be changing point by point. Now, if we then go from 0 to 2, when we put in 2 squared minus 3 is 1. All right, so from 0 to 2. One minus a -3 over 2 minus 0. It's going to give us 4 over 2, which is 2. And again, that's really giving you the slope of the line that connects those 2 points. Notice here that for the first one, we had a negative value and the parabola is decreasing, but it's not at a constant rate. The line has that rate of decrease of -1. Over here on this side, we've got a positive and its absolute value is bigger, so it's steeper. The rate at which it's increasing over here versus the rate at which it's decreasing from -1 to 0, we've got a steeper increase. Again, that's really giving you the slope of the line connecting those 2 points, but it also gives us a hint as to how the parabola is changing, even though picking different pairs of x's, that's giving us different average rates of change. More on average rate of change in just a bit.